The buildup of ice is a problem for many industries, interfering with the performance of aircraft, wind turbines, and power lines. It can be time-consuming and costly to remove. So scientists are developing surfaces that prevent ice from accumulating. They're making super slippery surfaces that not only keep ice from sticking, but also prevent ice from forming in the first place. Some use lubricants or tiny surface structures. Now, researchers at the University of Illinois at Chicago have made ice-resistant surfaces using simple molecules and phase-changing physics. The key to this frost-resistant surface is a family of materials that are liquid at room temperature and solidify above the freezing point of water. This property leads to some interesting phase-changing hijinks when water tries to freeze, and researchers have dubbed these anti-icing materials phase-switching liquids. At frigid temperatures, when added to a surface, the PSL forms a solid film. When water vapor in the air condenses onto a surface, it releases heat. The latent heat of condensation melts the PSL film locally to create a thin layer of liquid underneath and around the water droplet. See how these droplets slide around in the melted cyclohexane on this surface? The researchers think that it's harder for ice to form when the condensed droplets are in contact with a smooth and insulating liquid PSL film. They tested several phase-change materials, both in bulk form and infused into a textured surface, and found that dimethyl sulfoxide in bulk form worked best. A DMSO surface resisted freezing for more than 4 days at -15 degrees Celsius. That's 300 times as long as conventional superhydrophobic surfaces. Virginia Tech's Jonathan Borrico, who works with frost-resistant surfaces, called the approach from the University of Illinois team very clever, and said he'd like to see future studies investigate how exactly frosting is being delayed. Rukmava Chatterjee, a member of the Illinois team, says the group is now working to make the PSL films more durable and figure out the best way to apply them to objects.